biofeedback software share some common features. They all acquire a biosignal. They do feature extraction on that biosignal. And then for those favorable features, they provide positive stimuli. For those negative features, they provide inhibiting stimuli. All in biosignal.network, all that happens in the monitor view. And that's the subject of this video. The first one, which we're calling functions, covers the broader scope of the monitor view. The second follow-up video will dive into our way of doing feature extraction, which we call signal processing units, or SPUs. So let's go. We're going to sign in as Demo 1. We're going to pull up the monitor view by clicking the cog in the main menu. And then we're going to hide the video by unclicking overlay. Okay, so as we said, biofeedback software, the first thing they do is they acquire a biosignal. This over here controls the device. At the moment, there's not much happening because we haven't actually connected to it. Let's get device, click on it and connect. And we see a nice test signal coming through from the device. And we can see up here, this section here, which controls the device. It's highlighted test. If I click off, you'll see that the test signal is now gone and it's gone back to just showing some noise. Click test again, and it's gone back to the test signal. So this section here controls the device. Now, if you're just exploring and you don't have a device, then you don't need to use a device. You can, in fact, select some test signals. We have a sweep, and we can see it here in the frequency domain, sweeping up the spectrum. We have a step, which chooses a few different frequencies, and it stays for a few seconds on each. We have a simulated EEG that looks thus in the time domain and thus in the frequency domain. We have a simulated HEG signal. So for the rest of this, we're going to actually focus on the EEG simulated signal. You can see that, in fact, because we are not actually connected to a real device anymore, we're working on the EEG simulation, that in fact a lot of these functions have disappeared. And we end up with just the number of channels that are being generated by the simulation and the sampling rate at which they're being generated. Okay, so having acquired the biosignal, the next step is to do feature extraction. And the feature extraction is actually this black line along here in the frequency domain. The deviations, positive and negative, indicate which frequencies we want to encourage and which frequencies we want to suppress. This will be the subject of the follow-up video, as will all these control functions here. Let's go on a bit more here to media and protocol. We have libraries. Under media, we have the Biosignal 2D video library. And under protocol, we have the Biosignal EEG library. So under each library, there will be numerous media and numerous protocols. The intent is that you choose one that's near to what you want, modify it so that it suits your requirements, and then save it. And the act of saving it will save it in your own library, and thereafter you'll find it in your library. And as you are now the new owner, you'll be able to edit that and resave it going forward. Because, in fact, there can be and will be many, many, many media and protocol. We in fact provide filters here to separate them out. Down here again, we see that we've got two channels. Here represents the state of the channels. Now, as part of the protocol, in this case we're using Beta SMR Classic, there will be recommended sites on the scalp for channel 1 and channel 2, and in this case it's C3 and C4. The color of it indicates whether the EEG signal is fine or there's some issue. It's suggesting here that there's some issue with channel 2, and that's why it's gone orange. But channel 1 it's saying is okay. Now, if in fact we select a real device, we'll go back to QIS, and in fact you'll see that in fact it's changed now. It's now saying 0K. If you're in the mode, if the device is in the mode impedance, then in fact it's giving you a real-time indication of the impedance of the electrode scalp contact. And it's saying 0K. It's saying 0K because it's in test mode. Now, in fact, we don't have the device connected to a scalp. So if we take it off test mode, we'll see what happens to the electrode impedance here. And there it goes. It goes up to its maximum value because it's not connected. It's saying it's orange. It's flashing here to say we've got an issue. And it's showing its maximum impedance value of 255. In fact, to be a good signal, it should be less than 50 for both electrodes here. Now, we've got to say, too, that this particular protocol we've chosen is, in fact, a 2-channel protocol, and that's why it's showing channel 1 and channel 2. Had it been a 4-channel protocol, then we would have had the 4 sites represented down here, or had it been a 1-channel protocol, then there'd be just the 1 electrode showed here. Similarly, too, over here, we have the view of the scalp and the various sites on the scalp, and those that are recommended by the chosen protocol are reflected here. And they're saying channel 1, which is usually red, is C3, and channel 2, which is usually blue, is C4. If we choose a different protocol, we say wideband suppression, we can see, in fact, that protocol is recommending different sites. Okay. Now, if we're using a QIS, we in fact have control over the CAP interface. And these functions here allow you to switch between different sites in real time. And that will be the subject of a follow-on video. Okay, so that's the introduction. Next video will go into detail in all these functions down here under what we are calling the SPU, or Signal Processing Unit.